quality. We talked about this idea of quality last time, and again, this is a diagram that's in your resource guide. The main thing to understand is that quality is affected by cost, extent, and time. We have, again, highlighted the quality of a project, and it's determined by agreed upon requirements, schedule, and budget. It's referred to throughout the facility life cycle. We've discussed 3 parts, and the quality for each project is defined by the contract document, and it's based on lesser or greater requirements. But also note that it's the owner, not the architect or the design team, that have the greatest impact on quality. So there's the impact of quality, and that's where the owner comes in. And then there's the defined quality, which is where the A&E team come in. We're also going to talk about quality assurance versus quality control. And now we've got a slide with 2+ signs. So quality assurance is procedures for guarding against defects and deficiencies before and during execution of the work, and it's the plan. And I always look at quality assurance as what you can do, everything you can do to avoid having to be in a quality control situation where the event has already occurred. Quality control is the process for evaluating completed activities and elements of the design for conformance. The quality assurance, that's your plan of action, and quality control is the action. So QC may, for one action, may end up being the QA for the next step in the process. So here's some more examples of QA and QC. These are different types of activities. We're looking specifically at concrete. So to assure that we're getting what we specified, we're going to review the performance requirements forecast in place, and we might select a mixed design to submit to the AE through the contractor. What we would do for quality control, again, after, we're going to analyze that mixed design, and we're going to test it. So again, how are we going to assure that we're going to get what we want? And then once it's delivered, how are we going to check and see what we've received? Participants affect quality, and again, the idea is the owner establishes a level of quality. What the AE does, their role is to enable that QA/QC process to document and monitor costs and verify constructability. So controlling variables. And these are examples when it's times when variables are necessary, and this would be when you have an allowance, when you have an alternate, or when you have unit prices. These are variables to that overall cost. Under allowances, we have cash allowances and quantity allowances. As you'll see with the next slide, these type of variables, I personally try to avoid these type of variables because it does make the whole process extremely complicated. It makes it complicated from the owner's perspective as well, because we have to evaluate each proposal and be able to compare each proposal and make sure that everyone has the same information and everyone has the same understanding. So the advantages, it's a way to address an unknown or undefined issue during the construction phase, and that's probably the biggest thing you want to remember. It allows the owner a choice of products to add or delete based on the work. The disadvantages, a cash allowance, will suspend competitive bidding, quantity allowance. It has similar issues with cash allowances, alternates. There's a potential for inaccuracy and complexity in the bid process. And unit prices might be higher than the actual market. And again, highlighted and a plus sign, too many alternates may complicate the bidding and award process, and alternates must be formally incorporated into the contract. And again, that's underlined, and that would probably be a test type question, that it does become part of the contract. This is a table of when and where allowances, alternates, and unit prices are applicable. So on the left, you see the building element, and then selection, quantity, location. Again, the most important thing here is that alternates, allowances, and unit prices should be defined in Division 1. I always felt like Division 1, I guess early on in my career, it didn't make a lot of sense to me, I'll be quite honest, but I understand now that the most attention we need is actually to Division 1 in our contract. In Division 1, we'll have a clear description of work and inclusion. We're going to talk about cost estimates and estimating. Cost estimates, they are not prices. It's an opinion of probable cost. It's a guideline. It's how we're going to monitor costs during design. And as we do that, we need to account for changes to the extent, time, and cost. And there's different techniques. There's the order of magnitude, unit of measure, assembly systems, and unit prices. And move on to life cycle cost and value analysis. Again, we've got the plus sign. So it's based on the total cost of ownership rather than the initial cost. So again, depending on what type of owner you have, whether this would vary, but in most cases what we're talking about is whatever that first cost is, that first cost will affect the life of the building. The decisions made during design and construction will have implications for cost over the service life. Considerations that influence life cycle costs are things such as design decisions about materials, maintenance, operation, replacement, future alterations, additions, construction, recycling, salvage, disposal, obsolescence. Will this product still be available? The economic circumstances and the current technology that we have. Life cycle costs. They take into consideration, again, the entire life of the product, system, or facility. And these are right from your project delivery practice guide in terms of it involves resource extraction, manufacturing, on-site construction, maintenance, recycle, reuse, or salvage, and disposal. So the initial cost might be higher. It may be advantageous to an owner to spend more money initially for a better product with increased longevity. With that, when you're evaluating life cycle costs, I can say from the owner's perspective, as much as it makes sense to all of us as professionals to want to put money into that first cost, we also have to look at what funding is available. So what is the best option for that facility at this point in the life cycle of the facility as a whole? Value analysis, which most of us know as value engineering, and also known as value enhanced design. We're going to identify potential alternative methods, systems, or materials that will enhance life cycle value. And again, we might be in a situation where we can't put in the best solution, but what is the best solution that will allow, let's say 10, 15 years down the line, another investment in that facility. So earlier in the process is better than later, not always possible. The process involves collecting data, investigation, analyzing that data, reporting on it, implementing, evaluating. And so this really is more than cost reduction or cost savings. I know it has a negative connotation, but unfortunately we're all in that boat. We have to make a decision and make the best decision we can with the funding available. Now we're going to talk about documenting decisions. This is important to the whole group, to stakeholders and participants. It's important to record the decision, to have a historical record. It's a tool that the entire team can use. In addition to the drawings, it might include the preliminary project description, outline specs, design memos, meeting minutes, product notebooks, checklists, and it's a complex process. Sometimes it could be years, and we want to always keep open communication and positive communication within this whole design team, and documenting helps us do that. So we all have agreed to move forward in a certain direction, and what we've got on the slide is document, document, document. And again, I see this more as a positive exercise that we all agree, and this is not a finger pointing exercise. This is, yes, we agree, and we can move forward, and then yes, we can make changes as needed.
Suchi, just to chime in on that too, is what we're seeing too is the basis of designs, especially on projects that have lead projects that will have commissioning requirements later on. To document any of those changes, a simple change that you think in the wall system could definitely, throw off a lot of items in lead. Keep in mind that any of those, documenting that to make sure that you have an updated basis of design as you're going through the design process is critical.
But I think that's true for any substitution request that may occur or any value engineering. You need to make sure you use a substitution request form and document those, those changes and acceptance of those.
And I'm glad you brought that up, because I completely agree. I see documenting as a positive to kind of maintaining the morale of the team, the whole project team, and especially when the basis of design changes, and the fact that our commissioning authorities are kept in the loop. I think in the past, people have seen programming, basis of design, OPRs as kind of the, non-evolving document. You complete it and you file it away, but the reality is it does help everybody within the group. It avoids conflict, and again, we're all in it for the long haul. And I particularly prefer that the OPR does get updated, because if you are pursuing a lead project, that documentation is provided to GBCI as well. And that way you can explain why something was commissioned or was not, or why that change was made. So considerations to design, I think I skipped a slide. Great. The document decisions, we talked about different ways. I'm just going to go forward. So different considerations when we design: aesthetics, regulatory elements, functional, sustainability, constructability, and budget. You've all been to either engineering school or design school or whatever it might be, and you know that there's a focus on the aesthetics, but the reality is that's just one piece of the pie, and there's a lot of things that we have to comply with. I personally feel that great design can meet all of these categories. There's no reason that we compromise design for a regulatory requirement or for accessibility. I think that's part of meeting that design challenge. So we want to consider the owner requirements, regulations. What will the design be influenced by? Size, arrangement, elements, systems, components. It will be influenced by sustainability and budget. In red here is sustainability and budget. I really see sustainability as part of the process in the sense that it's more about energy conservation and operating and maintenance. I don't see this as an add to a project, but just good decision making throughout. The aesthetic, this has to do with our sensory responses, form, shape, volume, color, light, shadows. These are just some of the descriptions. And then regulations. Most important here is that there might be one more or additional levels of authorities having jurisdiction. We have the fire marshal in addition to the building official, and you have the elevator inspector. So there's a lot of different people we have to coordinate with and a lot of regulations to comply with. And with this being a university, of course, we also keep in mind what the statutes require us to do. So codes and regulations establish requirements for design and construction of new and renovated buildings. So it's a minimum level of habitation. And again, that's the other thing to keep in mind is that this is the minimum level. It's the fire protection of property and it's life safety. And the different types of requirements, building codes, zoning, deed restrictions, covenants. You can go through the list. You see accessibility highlighted there, sustainability, energy efficiency. All of you that work on public projects that relate back to the Florida Energy Code or aware that that's all linked back to our statute. I often wonder, it seems like we have to know quite a bit just to get one job done. The functional elements of a project, the relationships between the spaces, relationships to ensure proper function, and working with the owner and regulatory requirements. Adequate space, I'm sure you've all seen the need for mechanical space and other types of space increasing, affecting the budget in terms of the aesthetic that the owner might like to achieve. That would be elements that complement other elements, elements that challenge other elements. We want to have efficient flow and movement pattern, and we want it to be suitable to the construction type selected. So sustainability, it looks like you already talked about sustainability. It says discussed in session 1. Constructability. Here we want to review the documents to determine if design is practical. Does it make sense with the means and methods and products available within the time and the budget? We want to look at areas of design that might be difficult or impractical. What the image shows here is this extremely large canopy, and you might, I'm not sure where this is actually taken, but there may be other options that could have been incorporated, and so you want to look at all those options. Budget, we talked about that previously, and product evaluation and selection. We want to identify a product, evaluate it, and select it, and we want to select it based on performance requirements. We want to identify the attributes of that product, and do they comply with the requirements. We want to evaluate the history of the performance of that product, and we want to review compatibility with other products. A good example here is people continue to push for solar, but a lot of these solar laminate companies within a year or two they're gone, and as an owner you're left with something that you can no longer use. And so if you see some reluctance in using some of the newer products, that's why, especially with an owner that will hang on to a property 40, 50 years plus. Types of products, materials, commodities, standards, custom, assemblies, fabrication, and equipment. And we've got the plus sign here. We're going to talk about proprietary products and systems where we want to limit competition. Again, we need to look at this in a positive light, that if you have a large facility, it's actually sustainable to limit to a proprietary product because it is saving the owner in terms of replacement costs. We can't have X number of types of bulbs on a campus. You're having to store it, and having to store it also counts for budget issues in terms of space. Then we have listed here in yellow a single manufacturer and model number. There's a warning here down below about greenwashing and CSI's green format, which certifies manufacturers' product sustainable attributes. So the evaluation and selection process. We have initial product identification. We're going to establish the criteria, the types of attributes, the tests that we would require, the project requirements, the project delivery methods. And with evaluating that criteria, remember, of course, that the more we require, it does affect that project budget. Determine the applicable criteria for evaluation, other categories such as the physical properties, performance, sustainability, safety and protection, installation cost, and maintenance. So, product reps. This is an area that I think has really changed. I personally rely on our product reps. They are our technical assistants. They assist in preparing the specs and drawing, in estimating costs. They are, to me, an invaluable service. Whenever somebody is proposing something I'm not familiar with, I usually do reach out to that product rep to make sure that we're all in agreement that what we're using is the right product for the right application. And then we've got our review outline. So we talked about design, and this just lists everything that we've discussed today. That's it.
And do we have any questions? Yes. Okay. Don't have any questions at this point in time.
One thing I would like to kind of add to Suchi's presentation, if you're going to be pursuing the CDT exam, one of the things that's very important to understand is that that the difference between quality control and quality assurance. And so you saw an example of that, and we'll discuss that in a little more detail later in the future presentations. But make sure that you understand that concept. And she touched base on CSI's green format. And the CSI green format is primarily a repository for manufacturers to post their information, and the manufacturers actually certify the properties or their product capabilities, but CSI just provides a unified format electronically for searching those materials. So it's sort of like a Swedes catalog for sustainable product. And she also touched base on value engineering. Am I life cycle cost. So make sure you understand what those terms are and what they